Past exam question, we're going to have a look at using the Suvat equations both horizontally and vertically. So I've written a note here in case you wanted to have a look go yourself as well as the equations, but it's told you a student is, well, throwing the ball into the basket, and it's asked you to first draw the path that you'd expect it to take. So we'd expect it to go up to its maximum and then back down. You wouldn't really draw it going like that because it doesn't really make sense if then you just bounce off the sort of rim. Okay, moving on from that. It's told you the initial velocity of the ball on release is 4.5. And it's also told you that that 4.5 is at an angle of 60 degrees from the horizontal. So I'm just going to draw this arrow out larger actually. So it's a speed of 4.5 meters per second, but it's at an angle of 60 degrees. That's important that you take note of that angle. Okay. The horizontal distance from the center of the ball to the center of the rim is 1.5 meters. And it's asked you to find the time taken and show that it's 0.7 seconds. Okay, so let's break it down. First of all, we know that in air, we can assume that horizontal acceleration is 0. If we look at equation number 2, that means that the whole of the half at squared just equals 0, leaving you with s equals ut. That means that horizontally, in air, we can always use distance equals speed times time. Now, if you want to find the time, we rearrange that and say it's distance divided by speed. So it's the horizontal distance that's traveled from where it is to where it goes, which is 1.5. But then there's another trick to this question because the velocity isn't just 4.5 meters per second. It's the horizontal velocity that it travels with. What you need to do to find this is we're going to draw a right angle triangle out. We know that the component of the speed that's given is 4.5 meters per second, but that's at an angle of 60. We're only interested in the horizontal component. Because this is a right angle triangle, we know that this is the hypotenuse, this is the opposite, and this is the adjacent. And we want to find that adjacent. Let's call it x, because we're finding the horizontal. Using a and h, that's cos, we can form the equation that cos of the angle 60 is equal to the adjacent, which is x, that we're trying to find, divided by the hypotenuse, which is 4.5. Multiply both sides by 4.5, and we get that x equals 4.5 cos 60. Now, you don't have to put that in a calculator, you can just put it directly into this equation. Yeah, let's do that. It saves a little bit of time once you find that horizontal speed. This speed, by the way, is constant throughout the whole journey horizontally because, like we mentioned, acceleration is 0 horizontally. Putting that into your calculator, you'll get 0.6 recurring, or 0.67 seconds, which rounds to 0.7 seconds, so that's completely correct. If you do use this at any stage later on, by the way, try not to use 0.7, but use the rounded value that you found. It'll lead to more accuracy in the final answer. Going on to this point of the question, it now asks for the vertical displacement of the ball. So now we're using Suvat in the vertical direction. It's completely different. Now, because it's initially going upwards, the ball, in the vertical direction, we take the acceleration as minus 9.81. Because if it's going upwards, it's going against gravity, which is why we take into account the negative. So what's u? It's told you the speed is 4.5 meters per second, but at this angle. But we want the vertical component of the initial velocity. I'm going to bring out a different colored pen so you don't get confused. So we want this vertical component, let's call it y. We were given this speed and we were given this angle. What involves O and H? Well, it's sine. So we can say sine of the angle, 60, is equal to the opposite, which we're trying to find, y, divided by the hypotenuse of 4.5. From there, you can multiply both sides by 4.5 and you get y equals 4.5 sine 60. Which again, you can just put into a calculator and it'll give you 3.9. That's the initial vertical velocity because we're using Suvat in the vertical direction. Okay, so what are we trying to find in this question? It wants us to find the vertical displacement from where it is to where it reaches the net. And it wants us to compare it to the 0.7 meters and it wants us to check if a goal is actually going to be scored. Okay, so let's break it down. So what we want to find is the displacement at the time that it's sort of level with the net itself. We found that time previously in part I of the question. We found that it takes around 0.7 seconds for it to reach the goalpost horizontally, which is also the same as the time taken for it to reach the goalpost vertically. So we can use that 0.7 or 0.67 for more accuracy that we calculated before. And you want to find S. Well, what equation involves S, U, A, and T is that equation number 2 again. So S is equal to U multiplied by T plus a half of, so a half times A times T squared, 0.67 all squared. You put that into your calculator and you get 0.158, which is actually less than 0.7 meters, meaning that it won't reach that height of the net. Hopefully that all makes sense, and if you have any questions with it, just let me know in the comments. Otherwise, be sure to like the video if it helped, and yeah, be sure to subscribe.